All right, guys. So today we're going to be working on 12.3. So 12.3 is called meeting constraints. It says here's some situations that each relates to quantities, involves two constraints. For each situation, find the pair of values that meet both constraints and explain or show your reasoning. So it says a dining hall had a total of 25 tables. So that's important. Total 25 tables. And it says some long rectangular tables and some round ones. Long tables can seat 8 people. Round tables can seat 6 people. So again, important info. And then it also says on a busy evening, 190 seats for all the tables were occupied, right? So what it wants us to do is it wants us to make two separate equations. Um, the first equation that we're going to build, if you guys can see this here, I'll zoom in a little more. The first equation that we're going to build is going to be talking about our total number of tables, right? So what I'm saying is that if I have some rectangular tables and some round tables, those two things added up should equal a total of 25 tables, right? So that's what my first equation is going to look like. They give us right here that long tables are x and round tables are y. So we're going to use that fact and we're going to say that x plus y equals 25, right? That's going to give us our total table constraint. The other constraint that we can build is we can start building one for the total number of seats, right? So if we look back up, it says long tables can hold 8 people, round tables can seat 6 people. Okay, and we have a total number of seats of 190. So what I'm going to do is I'm going to attach the the 8 seats to the rectangular tables. So it's going to look something like 8x. And I'm going to attach the amount of people that can sit at a round table, 6, to my variable for round tables, which is y. So it'll look like 6y. Those two things added up, however many total seats I have at each, should equal 190, right? So that equation looks like 8x plus 6y equals 190, right? I'm just kind of building off the first equation to get to my second equation, okay? And it wants us also to be able to find this solution. What I did to find this solution is I went on to Desmos, I graphed these two equations, and I found where these two equations cross each other. These two equations cross each other at 25, right? They cross each other at the point 25. All right, so our next equation says a family bought a total of 16 adult and child tickets to a magic show. So a total of 16. Okay, it says adult tickets are 10.50 each, so that's kind of important. So I'll underline that. Are 10.50 each, and child tickets are 7.50 each. It says the family paid a total of $141. So this is a question that comes up a lot on all of our tests and quizzes. If I were you, I would even put a star by this one because it's really, really important, right? We have a lot of equations where we have something that has a total number of things and then a total price, right? So those are the two things we're going to build equations around. Um, we're going to build an equation around the total number of things we have. So it gives us right here, it says how many adult tickets A and child tickets C can they buy, right? So what we have is our two variables here, adult tickets and child tickets A and C. So what that means is that the number of adult tickets plus the number of child tickets should equal our total of 16 tickets here, right? And our equation for that, our total ticket equation would look something like this, right? A plus C equals 16. Again, if we're building off that, we can now make a price equation. So for our price, I don't want to cover that up. We have a total price of $141, right? So that's got to go into our equation. What we're going to do is we're going to build up how much we spent on adult tickets. So 1050 times the number of adult tickets, and then 750 times the number of child tickets, right? Both of those things will get us how much we spent on adult tickets and how much we spent on child's tickets. Those two things, the total of both of those should add up to 141. So that's what this is going to look like. 1050 times A plus 750 times C is going to equal our total of $141. Those two equations here, if we graph those two, will cross at a certain spot. The spot that these two equations cross at is 7, 9, right? In order to find these, what I did is I changed the A to an X and the C to a Y in Desmos, and I just looked at where they crossed, right? I put everything in that's right here, and then these two things will kind of make a little line that looks like this, and right there when they touch, that is that spot 7, 9. All right, so the next situation we have, we can read all this. It says, at a poster shop, Han paid $16.80 for 2 large posters and 3 small posters. So that's kind of important. We're going to make an equation for Han. So 2 large posters and 3 small posters. And then Kieran paid $14.50 for 1 large poster and 4 small posters of his favorite TV shows. Posters of the same size have the same price. So it says find the price of a large poster, L, and the price of a small poster, S. Well, what we can do, because we know how much each of them spent and we know what they bought, we can find the individual price for large posters and small posters. Okay, so what we're saying is 2 times the price of large posters and then 3 times the price of small posters should equal the $16.80 that Han spent, right? So that's what our first equation is going to look like. If I know that large posters is L and small posters is S, my equation for Han is going to look something like this. So 2 times the price of large posters, 3 times the price of small posters, add those two things together, and it should equal $16.80, right? But in order to find out how much he spent on both of them, we also have to take into account Kieran. So he paid $14.50. So 1 times the price of large posters, 4 times the price of small posters should equal the $14.50 that Kieran paid, right? And his equation looks something like this. Okay, what I did to find the solution to this is, again, I changed large posters to X, small posters to S, and I found, once I graph these two things together, that they do cross at a point. That point that they cross at is 4.95 and 2.30. So that means that large posters are $4.95 and small posters are $2.30, which kind of makes sense in the context of the problem. Okay, and that is all we have for 12.3.